mass. And the slide says, your notes say that atomic mass is measured in atomic mass units. So I want you all to repeat after me. The units for atomic mass are atomic mass units. Go ahead, you can, for atomic mass, are atomic mass units. So when I ask you what units atomic mass is measured in, you will never ever miss it. Because the units for atomic mass are atomic mass units. It's completely self-evident. It's absolutely a statement of fact. Now, remember when I said that we just pretend that protons and neutrons have the same mass? What we say is one proton has a mass of 1 AMU. One neutron has a mass of 1 AMU. If you would be so kind as to look at that periodic table, and somebody wearing blue, pick for me. Who's got blue on? Nobody. Okay, I lose. Somebody in red. Lots of you. Okay, there are 5 possible options. Somebody in red, pick your favorite element for me. Go ahead, Josh, pick fast.
American, you know.
Ooh, americium. Americium, boy, he went right straight for the big, fat, radioactive ones too. Okay, so we've got americium. It's down in the bottom row of your periodic table. Symbol is AM, and we're going to kind of dissect the entry in the periodic table for americium. If I can get a marker that works. So we have the symbol AM. Above it, we have a number. What is the number above it, Mr. Kane?
What do you mean the number above it?
The number above the abbreviation.
95.
95. And we have a number below it. What's the number below it, Mr. Burgess?
243.0614.
Okay. So we're going to kind of dissect this. The number on top is the what? Somebody in gray or black?
The atomic number.
The atomic number. So the atomic number is also equal to what? We'll stick with the gray or black. Number of protons. So atomic number is equal to the number of protons. What's this other number? Somebody in... We'll stick with gray or black until we've exhausted our answers here. Christian.
The one on the bottom.
Yeah, what's that?
The average.
Oh, okay, you threw in a word there. We're gonna keep it simple for right now. That's good. You know that. This is the atomic mass. Okay. And that atomic mass, we know, equals the number of protons plus the number of neutrons. Fantastic. Okay, good. That's established. And remember, we said we just take the mass of a proton and the mass of a neutron, we set them each equal to 1 AMU. Good, good. So let's figure out how many neutrons we have in americium. So the mass of americium is 243.0614. Well, first let's rearrange our equation. Atomic mass minus number of protons will give us the number of neutrons. Okay, fantastic. So now we can just plug numbers in, right? Atomic mass is 243.0614. What are the units for atomic mass? Atomic mass units. AMUs minus the number of protons, which we get from where? Somebody in blue or green? You're it.
The atomic number.
The atomic number. So we have 95 protons. What do we get for our number of neutrons? What do we get for our number of neutrons? 243.0614 minus 95. What do we get? Who's got an answer? Come on, calculators, calculators. Calculate, calculate. Mach schnell.
148.0614.
140, yes. 148.0614 neutrons. Does anybody have a problem with that?
Yeah.
Okay, we got one objection. Anybody else have any philosophical issues with that? Or practical or metaphysical or any other kinds of issues with that?
I'm sure
Cognitive issues with that?
Oh, yeah.
You got a problem with that, huh?
There's
You got a problem with that. A couple of you have a problem
You
with
have a
that.
problem.
Really? You got a problem with it, but we did the math.
Yeah, whatever.
You have two problems with that.
Yeah.
Okay. Explain one of them.
Alright. For one, my table here doesn't have like the 0.0614.
Is it just a whole number?
Yeah.
We're going to talk about that in a second.
But it doesn't have to do with it.
It does.
Okay.
It does.
That
What's your problem with it, Mr. Barber?
You can't have like 0.0614 of a neutron.
We can't have a fractional neutron. It's all or nothing, folks. You got one neutron or you got no neutrons. You got 148 neutrons or you got 149 neutrons. Huh. Well, this is troubling. So let's leave that alone for a moment, and we'll go back to some notes, and we'll see if we can't come back and solve this critical dilemma.